So my donor job is one of these. It's a GLADE Air Freshener. So what we're going to do is we're going to take it apart and make it smart. A big thank you to PCBWay for sponsoring this video. More on them later. They're quite easy to open up. You've got two ridges either side. So you just squeeze that and the top pops. Take the can out. We're going to need that later. Batteries. Don't need those. And then we need to take this thing apart. Best way to do this is turn it upside down and then just squeeze opposite corners and that just pops off. So in the actual unit itself, it's got these triangle screws, but you don't need a special tool for that. An ordinary terminal driver will get in those quite easily. So we'll take those out. Inside, we've got a board, we've got some gears and a little DC motor. This is held together by 3 clips. There's one there. We'll just lift that up. There's one at the bottom there. Just unclip that. And then there's one other at the bottom on the other side. So we'll just pull that out. Next up, we're going to take the board off. So 3 clips again. And one at the side. It's a little bit finicky. You've got to try and get all 3 of them at once. Cut the motor wires off that board. I'm still going to use that. We'll keep that to one side. The motor will come back to. We're going to cut the case up a little bit. So what I want to do is put a USB-C at the bottom here and then run the wires up to power it. And that will give it a nice steady base with the wires coming out the bottom. To do that, we're going to take off this gold brown trim. That's just held together with a couple of clips. So if you go in there, lift it up so it comes off the catch and then just wedge it back, it will come off of these sliders here which go into those grooves. So we'll just do the same for the other side. Get underneath it, push it back. Underneath, I'm going to mount a USB socket just inside here. So to get to the back of this, because I want to mount this at the back, I'm going to cut down that plastic all the way down to the back there. Now this is quite soft plastic, but it will take a little bit of effort, so do be careful. I'm going to run my knife along that edge all the way down to the back. Keeping my knife against this edge, I'm going to push nice and gently. A bit difficult to do at arm's length, but we'll try. So once it gets started, it does go down fairly easily. So just again, be careful. This is not the sharpest knife in the world. And then we'll do the other side. Slide it down. Once you get started, it does actually go pretty fast. But you can always trim it up afterwards. So yeah, and I'm going to take it down to that arch there on both sides. Again, just taking that down. Get a little wiggle. It's quite soft plastic. And then just with a pair of pliers, I'm going to rip that off. And then we want to trim it because, like I say, this one come down at an angle. So let's just trim that off. Almost like cutting through like a hard clay. So that's I could do it a little bit more. Let's just trim that off. And then again, that final back piece. So there you go. Doesn't have to be the neatest thing in the world. As long as that's the full width and you can test that out, the board should fit in there perfectly. So what I'm going to do is I'm going to line the back of that board with the inside plastic here. And I'm just going to mark where the back of that board lands in this groove. In fact, if I turn the light down, you can probably see that a little bit better. I'm going to drill a couple of 3.5mm holes. So the hole itself needs to be in front of that line, or behind that line if you're looking from the back of the unit. And I'm just going to drill a hole through there. Again, really soft plastic, so don't put too much pressure on. Just like that, just in front of the hole. It doesn't have to be perfect, you're not going to see it anyway. So we've got plus volts here and ground on the outside, so that's the 2 holes we drilled. Let's attach some wires to this. So for that I'm going to use a white wire, because the inside's white. So what I'm going to do is I'm going to measure from the base up to the top, or just over the top, and then I'm going to double it, because I need 2 wires. Get those stripped off and tinned. Blob of solder on the end there. And then on the underside of this board, I just need a big blob of solder on the 2 outside ones. So that's the positive and the ground. So a nice big blob of solder on that side. Nice big blob of solder on that side. Then I'm going to trim these off. Quite short. Like that. It's a couple of mil. And then I'm going to take the wire and the boards. And then I'm going to melt the 2 together so that the wire goes through the hole and is anchored there, so it just sticks up. Just gone through the hole there. So same on the other side. So solder on both, and then just you'll feel it go in. If not, there's enough solder there to hold it, as long as it's sticking out the bottom like that. Doesn't necessarily have to go through the board. So then I'm going to take the wires, cut them at the end, and let's feed them through the hole. That goes through there. Next I'm going to secure it in with a blob of hot glue, because the pressure is going to be, when I plug it in, it's going to be this way. I want a blob of glue behind it. And then we'll just put a little bit on the top, a little bit more on this side, I think, just to give it that corner. And I've touched the glue again. No! And then we'll turn the light down so you can see it. And then we've got those 2 wires coming in there. So we're going to put that to one side, let that cure. we'll concentrate on the motor next. So no more cutting. I'm going to get rid of the cutting boards because glue is always better for electronics. First thing I'm going to do is take these wires off. These wires are terrible. The core inside this is like the cheapest wire possible, and we're going to replace most of this anyway. Holding that top gear on, which will hold all of them on, I'm just going to melt the solder on these things and pull the wires off. On the board itself, we don't need these connectors. The only thing we're going to use on this board now is the push button, but you can just cut it. We'll get rid of that. So the button itself, we're going to connect two wires that we're going to bring back to our microcontroller, and that's going to be on these two pads here. So the button goes at the top, so it's those two there, and then I'm going to use glue for that. And again, it only really needs to go from the top of the unit there where the button is down to the motor there. So let's measure that. Let's have a little bit more. I want the wires coming off the left hand side here. So the first one, I'm just going to make a slight angle, and then we'll solder that wire on there, just so it's not in line with that second pin. So two wires come off the bottom two pins of that push button, and then this board can go back on the gear mechanism. So we'll just take that and snap that back in there, and then both of those can go round and into that little groove, and that should keep it away from the gears. So the first wire I'm going to take down through that bottom gubbins there and connect it to this side of the motor, the side that it's on. So I'm just going to cut that wire a little bit further than I need, get that one out of the way. And again, on that motor there, we'll have a bit more solder just to make it nice and fluxy. Bit of solder on there. And then I always find a pair of tweezers in tight spaces like this. Does make it a lot easier. Next up, I'm going to replace the red wire coming off that motor. Again, this silicone wire is a lot better than what was on there before. Blob of solder, cut the excess off, solder on the motor. Let's get the D1 Mini programmed. First of all, I'm going to add a couple of pins to 5 volts and ground. I'll take one of these things. I'm going to cut off 4. I'm going to cut it in half again. And let's think, carry the one. That leaves me with 2. And on the second set, I'm just going to pull the pins out of this one because I want the bit of plastic. So I'm just going to pull the pins out there. And then this bit of plastic, I'm going to put over the 2 pins of the previous one because I need a little bit more space. So now essentially I've got a double-sided little pin thing there. And this is going to go into 5 volts and ground.
Say hello to my little friend!
This thing is a variable adjustable regulator. So we've got an adjustment variable resistor at the top there, but also we've got several categories of range. So I've got 1.8 to 12 and then the adjustment on there. So what I've done here is I've blobbed some solder across the pair of pads for the 3.3 volts. And that variable resistor on the other side here, that's all the way clockwise. And then on the bottom there, where I've got the in plus and ground, I'm going to line those two up with the 5 volts and ground on the D1 Mini there. So let's solder that in. Now it's on here, we can plug it in and we can check the output of that regulator. Get my multimeter out, set that to 20V. So I should have 3.3 volts on that last two here. 3 volts is ideal. That's good. Now we can go on to programming the D1 Mini. PCBWay offers reliable PCB fabrication and assembly services, as well as 3D printing and sheet metal fabrication, all in one place. Say goodbye to the hassle of dealing with multiple vendors and save time by getting your PCBs made and assembled with PCBWay. With their great prices and high quality components, PCBWay is the go-to for all your electronics projects needs. Experience the convenience and reliability of PCBWay for your projects. Head over to PCBWay.com now to learn more. And let's make a new device. So I'm going to call this one Scent-a-Tron Lounge, and this is an 8266. We don't really care about this. I'm going to give you all the code you need anyway. So we go to edit, and then we go to my GitHub page where I've got the code for you. So we're just going to click on that, go up to here and go to copy raw file, back in the ESPHome, Control A, Control V. So we'll go back up to the top. So whatever you've called yours, make sure that that is the same in there, all lowercase obviously, and the room name is for the sensors and the button, which you'll see in Home Assistant once I bring it in. Let's quickly run through the code. Only one substitution, again that's the name of the buttons. Here are the intervals that I've set the timer to be. So I've got 5, 15, 30, 60 and 120. Feel free to adjust these if you want different timings. Just make sure that each one, as it says here, values must be in quotes. The squirt pulse is the amount of time that the motor is going to be energized. 100 milliseconds should be good enough. Don't go more than 150, 200, otherwise you could strip the gears. Ask me how I know. Like in my previous tutorial, one of these cans seems to be about 2500 sprays. Next up is standard D1 mini boilerplate. So we've got the device name. Restore from flash is true because we want to keep the canister level between restarts and power cycles. I've turned off the logs. We don't need to see all of that in the logs and it just spams it anyway. Feel free to turn these back on or comment them out if you want to see the logs for troubleshooting, and then the Wi-Fi credentials. So first of all, I've made a global called Squirts, and this keeps track of the number of squirts that the unit has made. I've also made another variable, which we'll get to in a second, but it's just for the timings of the button at the top of the unit. If I hold it down, it will reset the canister level. The binary sensor, which is a GPIO binary sensor, which is that little button on the top of the unit. That's connected to D3, which I'll show when I wire it up. So because I've made this a dual purpose button, a single press will do a squirt. A long press, and I've made this 3 seconds or 3000 milliseconds, will reset the can. So the first half of this code deals with a single press and it will show up in the logs as the button was pressed. Otherwise, or else, a long press will show up in the logs as can percentage reset, and it will reset the can percentage. That's on the sensor. We'll come to that. Next up is the select. As you can see here, it's the drop down select for Home Assistant and the interval. Again, we're using a name, Scent-a-Tron room. This time I called it interval and I've given it an icon. This has the options of off and the 5 intervals that I set in the substitutions. So these are called intervals 1 through to 5. And then down here, we've got that same substitution there, interval, and then after each one, I've put minutes. So it shows up as minutes in the drop down. So that'll be 5 minutes, 10 minutes, etc. Then the on value for this select executes the squirt timer, which is the next thing in my code, which is a script called squirt timer. What this does is it takes the interval select value, which is this thing here. You can see the ID, interval select value, and it will multiply it by 60,000. That's the default. Now for the demo, I set this to 1 second as opposed to minutes. So what the script does is it looks to see if the interval state is not off. So that's the first value here. So if the interval is off, this doesn't do anything. But if the interval is anything other than off, i.e. not equal to off, then it's going to wait for our interval duration, and then it's going to fire off a squirt. And all this is a switch called the squirter. That's the next thing down in the code. So the ID there, the squirter. This comes into Home Assistant as a switch. Again, this has got Scent-a-Tron, the substitution name, and Squirt. I've given it an icon. There's the pin, which we'll see in a minute when I wire up. So this has an automation. It's the on, turn on automation. And what that does is every time this switch is turned on, either in Home Assistant or within the code, then it's going to do something. First of all, the switch will come on. So it will fire the motor. There's a slight delay, which I've called Squirt Pulse. And if you remember back in the substitutions, the Squirt Pulse is 100 milliseconds at the moment. So back down, going to turn the switch on. It's going to wait for that 100 milliseconds. Then it's going to turn the switch off. So all I'm doing is activating the motor. 100 milliseconds later, I'm going to let go of the motor and the can is going to push the plunger back up to complete the cycle. And then every time it does that, it's going to add 1 to the number of squirts. Again, squirts here is a global variable. And remember, that's keeping track of the canister percentage. So it's going to add 1 to the canister percentage. Then it's going to publish the state of the can level sensor, which is the next thing in my code. It's going to publish the state by working out the maximum squirts. Again, maximum squirts is this thing here, max squirts, minus the number of squirts divided by the maximum squirts times by 100. What that will do will give you a percentage. So if it hasn't squirted, the percentage will be 100, and then every time you squirt, that percentage gets dropped down. Also in the logs, I just give you a little insert there to say I squirted, because putting squirted everywhere seems to be quite funny. Finally, in this block of code, I'm using global preferences sync with no parameters. Normally in ESPHome Code, this save to flash is set to something like 180 seconds or so. It's about 3 minutes. Well, we don't want that. We want the can and the global and everything else to be set as soon as it squirts, because if you squirt and unplug it, it's not going to remember that squirt for 3 minutes until it gets saved. So what global preferences sync with no parameters gives us is a way to invoke the right to flash. Finally, we've got the sensor, and basically what the sensor's doing, it's looking at the maximum squirts, it's taking away the number of squirts, which is our global value, dividing that by the number of squirts times it by 100. Again, it's basically a percentage calculation. And that's pretty much it. I've got an optional Wi-Fi strength monitor. Yeah, if you're in a bit of a low Wi-Fi area, that will give you some sort of indication. And then finally, a status LED. That's the LED. You can just about see it there underneath the regulator that we put on. So that's the code. I'm going to save that and I'm going to install it. Now this is plugged into my computer. As I showed you in this tutorial here, we now use the plug into the computer. So this is going to prepare and download the code. While it's doing that, I'm going to hit the open ESPHome web. If you remember, that opens it up in a new browser window. So I'm going to tear that off, make it smaller. I'm going to put that over there and I'm going to connect. Now my device is the serial port, so I'm going to connect to that. And then we're still waiting for that, so I'm going to hit install and wait for the file. As always, the first time you do this, it's going to take a while because it's compiling all the code in the background and all the sensors and all the log levels and everything else. Be patient, it is doing it. Right, there we go, finished. So I'm going to download projects. I'm going to put that on my desktop, like so, and we can close that down now. And all I'm going to do is drag and drop that over to the choose file button here. That'll load it, and I'm going to hit install. So what it's doing, we can bring that back up and move that over there. So that's going to erase the device. And if I turn the light down, we might get to see the light on the D1 Mini flashing. It is a status light after all. Yeah, you can just about see that underneath the board there. So it's doing stuff, it's installing. That's done. You can see the LEDs flashing slowly now. It's connecting to the Wi-Fi. That will stop in a second. So that's connected to Wi-Fi. And as you can see down here, we've got a notification to say that it's found a new device. Scent-a-Tron Lounge, there it is. So I'm going to configure that. I'm going to put this in the office and let's have a look at it. Scent-a-Tron Lounge. And if I make this really small, so it formats the page a little bit better. So there we've got the Scent-a-Tron Lounge interval, and that's got our off and then our minutes set. We got the Scent-a-Tron Squirt, that's the switch we showed. Again, if I click it, 100 milliseconds, it disappears. And also you can see, as I'm squirting, the count percentage is going down. Now, even though I've given the button a name, it's not showing up in Home Assistant. Obviously, being a binary sensor, it's a sensor. I've disabled it by default, but if you want to turn it on, you can just go here, go to here, hit enable, and then for some reason, the Home Assistant will take half a minute for it to show up. I'm not sure why, but there you go.
A few moments later.
So this is the button on the top. Now, put it in here. That way you'll get a history of when the button was manually pressed. Back on the D1 Mini board setup, we want a wire from D8 there to that first connection of the regulator. That's the enable pin. The reason why I'm using this is it's a regulator, but it's also got an enable disable. So with nothing connected, as we saw when we tested it, the output is enabled. If we take that pin low, we can turn this off. So let's add a green wire between D8 and that one there. You can just about see that poking through there, hopefully. So I'll solder that on. Next up, we can connect this to the board. If you wiggle it about a bit, you should find a nice place where it sits flat. You don't want it going above there because it'll interfere with the case. Find a nice place. It doesn't have to be perfect. There's plenty of space in the back here. I've got all this space, so I'm going to connect the red wire that came from the motor, and that's going to go on the output of our regulator. So I don't need a lot of wire, about that'll do. Cut that, tin it. Again, plenty of space, just make sure that nothing's going to go into these cogs and fail them. I'm going to tin that. Again, I'm going to go on the underside because it's going to be a bit difficult to solder on the bottom of this board. Make sure that's reasonably straight there. Nice lot of solder, nice lot of heat. There's quite a lot of tracking underneath that pad. So a little bit there, I can cut that off just to keep that nice and neat. Next one is the second wire from the button. The first wire went to the motor. The second one, that's going on D3, which you can just about see underneath there. So again, don't need a lot of wire, so I'm just going to measure that to roughly there will do. We'll cut that. Again, we're going to strip it and tin it. A little bit of solder on there. Cut that off. I say D3, so I'm going to come in through the top side here, round, bit of solder, hold it down with a middle finger, and just going to connect that to D3. I'm going to get another blue wire from the 0 volts of the motor to the 0 volt pin of our regulator, and also remember that's also connected to the 0 volts of the D1 Mini. I'm going to use another blue wire for that one. So we'll just tin that. We're going to have a nice blob of solder at the base of that, and then we'll cut that off. And the 0 volt on that board is the third one up. It's the second one for the D1 Mini, but remember this is overlapping by one, so it's the third one up on this board. What I'm going to do, I'm going to come in the sides and I'm going to try and hit the pin and the wire at the same time, so both solder on those will melt together. Like that. It looks like it's joined, it's because it's shiny. So just make sure that there's no bridges between those two. There's a little gap there, but that should be okay. And then this blue wire, that's going to connect down to that wire as well on the motor. So I'm just going to clean that off. We want a nice blob of solder on this one. Big lot of solder on there. Cut that off. And then this one, I'm going to come off the back and then use my fingers. I'm going to hold both those wires on there and then with the solder on, a little bit of solder on the tip. I'm going to melt through the wire I just put on, through to the bottom one, and there you can see they're both on there. We want to make sure that that's not touching the case. So just to make sure, I'm just going to pull them up a little bit so that they're a reasonable angle off the case of that motor. That's the D1 Mini connected to the unit. We just need to bring power to this now. That's from the base that we made. So let's turn the light down because that's really white and really reflective. So as you remember, we put the Type-C socket on there, hot glued it in, run the wires through, and I've also cut these bars and run the wire through the center and a little bit of hot glue on each one there. Looking at the back of it, the left side is plus. You can just see the V there and just about see the ground. If these wires are straight, it's going to be this wire that's plus, but always best to check. So I'm just going to pull that one off. Get the multimeter, set to diode or continuity mode. And I want to come off of that one on that wire. So I'm just going to touch that pin on the V. As you can see, that's gone down to 0. And then now we've identified the plus, I'm just going to put a little knot in it, just so I can identify it in a second. That's good. Now these wires, the plus will go to the regulator. The 0 volts is going to connect to that one as well. That's going to sit in that way round. If I cut those off a little bit over the top there, I think that's going to be fine. So let's do the plus volts. We'll take that off of there. We don't need that much wire. And then I'm going to strip that. I'm going to tin this. I want a nice blob of solder right on the base there. I'm going to cut off everything else. And then that one is going to the plus volts of the regulator, which is also the 5 volts of the D1 Mini. So like we did with the blue wire there, nice blob of solder on the iron. And then I'm going to solder that one. Again, touching the pin and the wire. I'm going to melt those two together. See, they're not connected. And then the other wire from our socket, that's going to connect to that motor 0 volts as well. So again, don't need much more than the top of the case. I'll just trim that, strip and tin that one. Nice little solder on there. Again, I've tried to make a blob on the base. Cut that off, millimeter or so. And then we'll take that off to the side. This one can come off on this direction. So then just quickly, just tap that onto there. So again, I'm going to try and find a good space that's not above the mouldings there. It doesn't have to be flat. There's plenty of space behind this. So that feels reasonably flat there. Let's dump a reasonable amount of hot glue on this to hold it on. Doesn't need to hold that much, so I'm just going to put a blob of glue there, a blob of glue there. We'll let that cool down a second, and then I'll put another couple of blobs this side just to hold it. So in there, avoiding that reset button on the D1 Mini, and we'll just wait for that to cool down. Let's put this back on. You can see the clips, and then just push down on those like that. This little moulding here is where the back of the motor sits, and as you can see, it's slightly to the right in this view. So what I'm going to do, I'm going to route my wires this side, and in that way it ensures that it's away from the back of the motor, just like that. And we can put our 4 screws back in. They don't need to be tight, they just need to hold it. I'm just finger tightening these. There's really no need to do them up tight. Now for the trim on the back, we need to cut a hole that's similar to that in the back of this. Well, on the back here, you'll see some circles. And if we drill another 3.5mm hole, 7 o'clock here and 5 o'clock here, and join them together, that's going to line up pretty nicely with our hole. Let me show you. Little block of wood there, 3.5mm drill bit. So I'm just going to drill a hole there, like that, and then using a knife, I'm going to connect those two together on the end of my block there, I think. Does that work? So just using the blade, I'm going to just push down, give it a little wiggle, and again, both sides. And I find if I turn it round and do the other side, it just makes it easier just to get that initial score on both of those. So yeah, again, with this plastic, take your time, firm but steady pressure. I say it's really soft, so it won't take a lot of cutting. Alright, so just get rid of these burrs. That'll do. So this thing, we've got a couple of grooves on there that's just slide into these funny shaped holes. So just line it up there, push it forward to it clips. Same with the other side, line it up, push it forward to the clips. And there you go. I'm a lot better at soldering than I am cutting plastic. Right, now another thing we need to do is just make sure this plunger is all the way up into the base. And you're just going to grab a screwdriver and just gently, not too fast, just push that back up. And then we can get a can, line that in there. That fits us quite nicely. Now to put the lid on, first of all we're going to put the top on. That clip goes into that square hole there. And then we'll just clip that in. And then we just simply line up that groove in those holes there. See that slide in? These in there, and then just push it together, and you're done. So we'll just squeeze that off, put the can back in, and then we'll do a test.
Well, I hope this video was helpful with your projects. Please do share it so others can find it as well.
I upload videos whenever I can, so subscribe and hit the bell icon to get notified. That's it. Thanks for watching.
Okay, I love you. Bye-bye.